Alright, so for this video, we are going to discuss how to actually sketch the histogram correctly. Okay, especially for the unequal histogram. Alright. Okay, so before we start, please take note every time when you want to sketch any graph, right? No matter it's histogram or cumulative frequency graph, as long as you want to sketch something in the graph paper, generally you have to use the sensible scales. What's the meaning for sensible scales? To me, I will call it as good scale or good value, such as 1 cm for 1 unit, 1 cm for 5 units, 1 cm for 10, 1 cm for 20, or 1 cm for 50 units. Okay, then rather than you use a very weird value like 3, 7, 23 unit like that. Okay, so try to use 1, 5, 10, 20, or 50. Okay, alright, so why do we need to have this kind of scales? It is because of, first, if let's say they want you to use your graph to estimate the values, then you will get much more accurate answer because it's very easy for you to estimate. If you use all the weird value like 3, 7, 11, all those things, right? Later when you want to estimate your value from the graph, it will be a nightmare for you. Okay, so please make sure that you use all the good skills here. When you want to draw histogram, not any histogram actually, all kind of graph cumulative frequency also the same, cumulative frequency graph. Alright, okay, so let's have a look for example 6 here. So can I have a look at example 6, and then we have what, example 7. Okay, and then example 8. There are 3 examples here. Okay, good. Alright, so maybe what should we discuss? Maybe we can discuss example 6. Wait, I'm thinking to let you try one example yourself. Okay, but never mind. I discuss all with you because they have different details. Alright, then maybe you try the tutorial question later. Okay, so now they give you example 6 here. This is the table that they give you with frequency, and also they are talking about the time. Okay, the duration of the telephone call. Okay, and then first they want you to draw a histogram, of course, and after that they want you to estimate the number of calls with duration between 5 to 13 minutes. Okay, so how can we do that? Alright, so first we need to draw the histogram first. Okay, so before you draw the histogram, last time when you want to draw, right, you straight away draw nothing special one, right? You just straight away draw the histogram, follow the bar and so on. But now there are a lot of things that you need to check. The first one is you have to check whether you have class boundary or not. So how to check whether is it class boundary or not? So you check on the upper value for the first class and compare it with the lower value for the second class. Are these two values the same? If they are the same, that means you don't need to do any adjustment already. This is already the class boundary. Therefore, before I draw the histogram, I will write out the class boundary first because I no need to do any adjustment, right? So straight away I will write 1 to 3, and then 3 to 9, 9 to 15, and also 15 to 20. Okay, so once I have my class boundary already, the second thing is I'm going to find the width, to check on the width. So what's the width here? The width here is 3 minus 1, you get a 2. 9 minus 3, you get a 6. 15 minus 9, you get 6 also. And then 20 minus 15, you get a 5. Okay, so make sure you know how to get the width here. Alright, so last time when you learned histogram, right, you didn't actually go and check the width one. But from now onwards, please make sure you check the width before you draw histogram. So if you look at the width here, you're having different values, 2, 6, 6, 5. As long as you have different values here, generally you have to draw unequal width histogram already. Okay, if let's say all the width here are same, then okay, it is still the normal type of histogram. Okay, but when you see two different values, okay, as long as got any different values, then you should draw the unequal width histogram. So when you want to draw unequal width histogram, you need to create another column we call as frequency density. Okay, right. So for the frequency part, nothing special. You just try to copy it from the table given. Okay, so frequency density again, just to remind you, what is the formula for frequency density? It is equals to frequency divided by width, right? Alright, so For the first frequency density, you take 10 divided by 2, you get a 5. Second one, 42 divided by 6, you get 7. 12 divided by 6, you get 2. 7 divided by 5, you get 1.4. Alright, so this is what we have before we sketch the graph. Okay, we sketch a histogram. So the most important thing is you have to double check on the width first to check is it the unequal width histogram or not. Okay, if you confirm that it is unequal width histogram, then the next thing you need to create is the frequency density. Yeah, alright, so now we can start to sketch our graph here. So for information, class boundary will be my x-axis, and the frequency density will be my y-axis. Okay, and then how should I sketch the graph? Okay, so I will bring this up. Alright, so I hope that you can see the table, the value that we have just now. Okay, so this is a graph paper that I provide to you. You will see that it is actually not the whole graph paper. Okay, it is only part of the graph paper. Okay, alright. So now, in A-level, actually they are not requesting you to draw a very, very large graph. Alright, they just want to have a clear graph. Clear graph means that as long as the scale is okay, and then everything that you draw is fine, okay, then they will accept it. Okay, alright, so this is something that you need to know. Okay, alright, so now, let us start to draw the histogram. Okay, so to draw the histogram, first, I will look at the smallest value here. The smallest value that I have in the class boundary is 1, and the largest value is 20. Okay, so if I look at my graph paper, all right, so I think the suitable scale that I use is, if you want to make it smaller, also can, like 1, 2, 3, 4, 5, 1 cm for 5 units. Is it too small? Because 5, 10, 15, 20. Then your graph is too small, all right. Maybe you make it slightly larger. Okay, so instead of 1 cm is 5 unit, you make it 2 cm as 5 unit, maybe better. So you have 5, 10, 15, 20. Okay, so maybe I can do it like that. All right, so I will draw the graph here. I will try to put in all the label first. Okay, so I'm sorry because I'm using the bamboo pen, so it is usually quite impossible for me to draw the very straight line. Okay, so please bear with me for this. Okay, so maybe I will take 2 boxes, 2 cm as 5 unit, 5, 10, 15, and then 20. So to me, this kind of graph is good enough. All right, it is, you learn to put it until very full. Okay, so at least this one is slightly more than half of the graph, that is okay. So here is 0. Okay, so for the x-axis, you can label it as duration, or you can label it as class boundary. Duration means according to what they give you in the question. Alright, so this is duration. Okay, and then you can label it as t minutes if you want. Or even if you want to put just class boundary, also can. Alright, then now we look at the y-axis. So for the y-axis, frequency density, the highest value is 7. So very easy, I think I will put this as 1 unit, then 2, 3, 4, 5, and 6, then 7. So I label it first. This one will be my frequency density. Alright, okay. So once everything done, then I will start sketching the histogram already. Okay, so for the first class, if I refer to the table, first bar should be between 1 until 3, and then the height is 5. Okay, so from 1 until 3, the height is 5. So you have to calculate where is your 1 until 3. Okay, so my 1 is here, then 2, then 3, 3 is here. Okay, so from 1 until 3, the height is 5. So maybe you can draw the first bar like this. Until 3, right? Okay, so this is 1 until 3. Sorry, I cannot draw a very straight line. Please bear with me. I try my best. No matter how I try my best, but if it is not straight, then it's okay lah. Okay, so I'm having this. All right, but in exam, you should draw a straight one. Please use ruler to help you. Don't tell me that, oh, teacher, I feel very panic, and then in exam, I will feel very tension, I shivering. No, okay, please use a ruler to help you. Okay, so this is the first bar that we have. Okay, then how about for second bar? So for the second bar is this from 3 to 9. 3 to 9, and the height is 7. So this is 1, this is 3. Then where is the 9? 9 should be somewhere here. This is the 9. And then the height is 7. So that means here lah. So when you draw the bar, it will look something like this. Until 9, right? So this is 9. Ayo, okay, I'm trying my best. So this is my, so this is the second bar. So it is fatter actually. Can you see that? Okay, then after that for the third bar is from 9 until 15, and the height is 2. Okay, so until 15 and the height is 2. Very easy to draw this one. Until 15. Okay, and then how about the last one? So the last one is 15 until 20, and then the height is 1.4. So you're having 1, 1.2, 1.4. 1.4 is here. All right, so this is how your graph look like. Okay, so if you have a look for the histogram here in overall, you will see that actually the width of the bar are different. That's why we have the frequency density as our y-axis, and also the bar different width. Okay, all right. So generally, this is the idea of how should we sketch it correctly. Okay, So you should try out on your own. Okay. Any question to ask? If you have any question, not so sure, you just ask me through Facebook Messenger. All right. Okay. So before we continue to the next part of the question, right? When you want to draw the histogram, some students will tell me already, okay, teacher, I know how to draw the histogram already. Okay, so do I need to show this whole table, okay, in exam or not? All right, so usually my suggestion is like that. If, let's say, you are the students who need to know all the every single step before you can draw it, then better you draw the graph, draw the table to help you. Okay, but if let's say you are the students that without writing out the class boundary, interval width, and so on, you already know how to sketch it, you can skip this table, but, okay, listen carefully, there's a but here. In somewhere in your calculation or somewhere in your graph, you must show me all the value for frequency density. The frequency density value must appear in somewhere of the calculation in your solution. Okay, so you cannot tell me, teacher, no need to write out because you can just let the examiner look at the graph and they know what is the value. No, okay, they must see all the value must be seen, because usually they will state out clearly the values of frequency density are correct. That means they actually want you to list out all the value for frequency density. Okay, so if you are not so sure whether is it correct or not, just put in all the table, everything in the table. But some students say, oh, it's really time wasting when you want to draw everything in the table. Then you can just show the frequency density before you sketch the graph. All right. Okay, so this is what we have. Okay, for drawing the histogram. So I hope that you have an idea how to draw it already. Okay, that's to the second part. Okay, so after you draw the histogram, right, sometimes they will actually ask you to answer some question by using your graph. Okay, so as an example, they want you to estimate the number of calls with the duration between 5 minutes to 30 minutes. Okay, so if you look at the graph here, do you have any 5 minutes to 30 minutes here? No, right? There's no 5 minutes and 30 minutes here. They want you to estimate the value from your graph actually. Okay, so your graph now is very important. 5 to 15. Oh, sorry, 5 to 13. 5 to 13. Wait, yeah, 5 minutes to 13 minutes. Okay, how can I use my own graph to estimate the value from 5 to 13? Okay, wait. Okay, sorry. So I think I have to do it like this. Okay, 5 to 13. Where is 5? 5 is here, right? Okay, so this is 5. 13 is where? This is 10, 11, 12, 13. 13 is here. Okay, so from 5 to 13, should I use the thicker pen? Okay, so when you are having 5 to 13, generally, you need to know what is the value from here, okay, until this part, and also from here until here. Okay, so I want to calculate the frequency for these two area now. Okay, so just now I think I told you already, right? What is the frequency? So frequency is actually frequency density multiplied with width, right? So you should know that to get the frequency, it is equals to frequency density multiplied with the width. Okay, so first, I look at the first graph here. What is the height? So it is 7. Multiply with width. What is the width? From 5 until this value. This value is a 9, right? So 5 to 9 is 4. So you multiply it with 4. And after that, you plus. Plus what? Okay, so the second bar. So second bar, the height is what? The height is 2. Multiply with 9. Oh, sorry, it's 13 minus 9. You also get a width of 4. So eventually, what do you get? 28. Okay, plus 8. So the estimate value that is between 5 to 13 minutes is 6. Alright, so they actually want you to use your own histogram to try and estimate the value. Of course, if you draw it wrongly, then you cannot get the answer correctly. Okay, so this is what we have it. So make sure that you know how to apply it, apply your graph, try to find some useful information from your graph to answer the question. Alright, so now we discuss another example of drawing histogram. Okay, so let us have a look for example 7. Okay, so again, if you look at the data here, they actually want you to represent the data in a histogram. Alright, so similar like what you learned before. Okay, before you want to draw any histogram, every time you have to double check and see whether you need to do any adjustment to change it become class boundary or not. Alright, so we always check the upper value, okay, for the first interval and also the lower value for the second interval. Alright, so you can see that the first interval upper value will be 19 and the lower value for the second interval is 20. So these two values are different. So these two values are different, which means that there's a gap between them. Alright, so you need to do the adjustment, okay, to make the class interval become class boundary so that it becomes the same value. So how to make the 19 and 20 become the same value? For all the value of upper class interval, you need to plus 0.5. And for the lower value, okay, for every single class interval, you need to minus 0.5. Okay, so this is something that we need to do. All right, so let us try to complete the column for class boundary. Okay, then for the value 0, I will just keep it first. I don't touch anything yet. Okay, I will start from the 19. We will have 19.5, right? Okay, and then 20 minus 0.5, you also have 19.5 after you adjust it, and then 39, it will become 39.5. Next class, 39.5 to 89.5. Okay, and then the last one will be 89.5 to 189.5. Alright, so from here, you can actually see that after you do the adjustment, all the value, okay, for the classes and between all the classes will become the same value, which means that there's no gap between them. So that's why from here, you already get your class boundary. Alright, okay, so don't forget every time before you want to draw the histogram, the very first thing now you need to check is do you need to do any adjustment or not to change your data become the class boundary? So that's the first thing. Okay, then do you still remember just now we skipped the value 0? All right, so there's a special case here now. Okay, when your data start with value 0, you need to be extra caution because we have different cases here. Okay, so please take note here. All right. Okay, so please make sure that you take note on this part when the grouping starts at 0. So only this is the special case when your grouping starts at 0, then you need to consider whether your data is discrete data or is it the continuous data. Okay, so what is the meaning of discrete data? So as what I told you before, discrete data means something countable, like talking about the number of students. Okay, when the data talking about the number of students or maybe the number of cars, all these are actually discrete random variable or discrete data. Okay, so the students and also the cars are countable. All right, and for continuous data, in general, we measure the variable such as weight, okay, then length, height, okay, volume. Of course, volume also belongs to part of the continuous data, and there are a lot more. All right, so if let's say you have the grouping start with 0, okay, if you are having the discrete data, all right, then your histogram, you have to adjust it become negative 0.5. Okay, so you're allowed to adjust it. If let's say you need to adjust, then you can adjust it become negative 0.5. If your data are continuous data, okay, then you will not need to actually adjust your 0 become negative 0.5. Okay, so this is a small difference in this detail, okay, for the discrete and also the continuous data. And please take note that not all syllabus will include this. Okay, so I'm yet to find out the reason why we need to consider something like this. Okay, but if let's say you found any useful information, you can always let me know, right, the reason. Okay, so if you go for other reference book, they might not actually mention all this detail here, right? Okay, so I just want you to take note on this. Okay, so if you have a look for our data, okay, our grouping start from 0, so I need to consider whether my data belongs to continuous or discrete data. So they are talking about volume. So volume is something that we measure, right? So this one is continuous data. Okay, therefore, you no need to adjust the 0 become negative 0.5. So you just keep it as 0. All right, so that's why my class boundary here, this will be a 0. Okay, then now the next, so after you settle the class boundary, the next one we are going to consider the interval width. All right, so for interval width, because you need to check and see whether they are equal width or non-equal width, right? Okay, so for this interval width, in general, you take the upper class boundary minus the lower class boundary. So for this case, the first case you're having 19.5. Okay, then 39.5 minus 19.5 for the second class, you have 20. Okay, then 50 followed by 100. All right, then how about for the frequency? So for the frequency, you just copy, okay, from the frequency distribution that it give you. All right, then now we talk about the frequency density. So if you look at the interval width, you will realize that for this column, right, the width are different. Therefore, when you want to sketch the histogram, you need to sketch histogram with unequal width. And the y-axis for histogram with unequal width will be frequency density. So you need to have the value for frequency density in your solution. Okay, how to get the frequency density again? So frequency density is equals to frequency divided by width, which means that if you take 10 divided by 19.5, you have 0.513. Okay, then the second class will be 0.4, then 0.24, and also 0.2. Okay, so once you are done with all the data already, then you can start drawing it up.
Okay, so please take note that in exam, you must show the value for the frequency density somewhere in your solution. You cannot just ask the examiner, okay, to just figure out or maybe just to read the frequency density value from your graph. You have to list out clearly in your solution, right? Okay, so let's continue with the graph drawing part. Okay, now I want to draw histogram. Okay, so to draw the histogram, what I will do here is I will have the zero start from here. Then maybe this is 20. Like every 5 boxes will denote 20 units. Okay, so 20, 40, 60, 80, 100, 120, 140, 160, 180, then 200. So it is more than enough. Okay, so our label for the x-axis will be volume to the nearest, okay, milliliter. All right, then don't forget about our y-axis, it will be frequency density. Okay, our frequency density highest value is 0.513. Oh, okay. I think the graph that I prepared for you here will be is a bit too small. All right, but never mind. Maybe we just try to draw it a bit out. Okay. All right, so this is 0.5. Okay, so for the first class, it is from 0 until 19.5, and the height is 0.513. So start from 0 until 19.5. So 19.5, it will be very close to 20. Okay, but just to show you, all right, if let's say in the exam, if you can draw a better scale, then you can draw it. So the 19.5 didn't touch the 20. Okay, but it is very close to 20. So the height will be slightly more than the 5. Okay, right, so it's 0.513. Okay, then from 19.5 to 39.5, we should have 0.4. So 19.5 to 39.5 is 0.4. Okay, 0.4 is at this height. 39.5 means very close to 40, but didn't touch the 40 yet. Because my scale is too small here for the x-axis. If you can draw it bigger, then it's easier for you to measure. Alright, 39.5 to 89.5. So 39.5 to 89.5, you will get 0.24. So 0.24 will be somewhere here, the height. 89.5. Okay, 89.5 means very close to 90, but didn't touch 90 yet. So the 90 is in the center here, right? Yeah, so again, my graph might not be very clear, but you can actually try to enlarge the scale if you have enough space in the exam. Okay, then the last one, 89.5 until 189.5 is 0.2. So 89.5, you start drawing it until 189.5, which is very close to 190. All right, so you will see that this is actually the graph that you get the histogram, and you will realize that the width for the bar are different. Okay, and you will see that the y-axis here will be the frequency density, not the frequency that we learned for the equal width before. Okay, all right, and of course, not to forget the special case here, when you're having any grouping with 0, then you have to double check whether your data belongs to discrete or continuous data. If continuous, then you no need to adjust it become negative 0.5. If it is discrete data, then you have to adjust it become negative 0.5. So for our case here, volume will be the continuous data. Therefore, you see that this value itself, I didn't change it become negative 0.5. And end up my graph looks something like this. Okay, all right, so hopefully you understand this question, and maybe you can answer the part B, state the model class. So when you're asking for the model class, we will actually write out the class interval, okay, with the highest frequency density. please take note on that. It should be the highest frequency density. So the highest frequency density is actually the first class, which is 0 until 19. Okay.
Like example 8, they give you a histogram and they actually want you to convert it back into a table. Okay, so this I think is not hard actually. Okay, so first they ask to construct a frequency table, and after that they ask you for the percentage of something else. Okay, so let us start now. Okay, so when you want to write out the classes here, right? So you need to look at the bar. So you're having 1, 2, 3, 4, 5, 6, 6 bars here. Okay, so for the first bar, it is from here until here, which is from 0 until 5. Okay, then the second bar is 5 until 10. Okay, then you continue the rest yourself. Okay, then how about interval width? So the interval width will be very easier. So 5 minus 0, you get a 5. 10 minus 5, you get a 5 also. Okay, 20 minus 10, you get a 10, and so on. Okay, then for the frequency density, what you do is you try to read the value from the graph. The scale that they use is very clear also. Okay, so you try to write down all the value and read it from the graph. Okay, so if you didn't do any careless mistake, your frequency is 6.4, 8.8, and something else. Okay, I'm not going to show you everything, but I want you to try out on your own. Then how frequency? So again, to get the frequency, the formula is frequency density multiplied with the width. So for the example, first frequency is 6.4 multiplied with 5, and therefore you get 32 for the first class. Okay, then the second one is 44. The third one is 28, then 12, and then 12, and then 6. These are the answers that you should get. If you didn't get the answer frequency as what I shown here, that means something wrong in your calculation. Okay, so please make sure you double check. So this is the this is how you can check your answer whether is it correct or not. Okay, right. So after you construct a frequency table already, then you answer the question. So what do you want? What is the percentage of the train were less than 20 minutes late? So less than 20 minutes late. Okay, so they are talking about lateness, right? So less than 20 minutes late will include of this frequency. This is less than 20 minutes. This is also less than 20 minutes. This is also less than 20 minutes. So to get a percentage, how should we get it? Okay, so you should get 32 plus 44 plus 28 divided by all the total, right? The total of the frequency. So the total of the frequency is 32 plus 44 plus 28 plus 12 plus 12 plus 6. Okay, and because they are asking for percentage, so you have to multiply it with 100%. Okay, so when you try to press calculator and get the answer, okay, so what is the answer that we should have? Okay, so you should have 104 divided by 134. Okay, then multiply it with 100%. Final answer that you should get is 77.6. All right, 104 divided by 134. Okay, so this is the only answer, 77.6. Okay, wait my file is auto saving and it is hanged. Wait for a while. Okay, so this is the final answer. So maybe some of the students will say, why should I write it as 77.6? Can I write some other answer? Like if I press calculator, I can be 7.61. Or maybe you write 78%. Okay, or maybe some students say, can I write 77.612%? More accurate, okay, more decimal places means more accurate. Okay, if you write all the answers shown, all these are wrong. The only correct answer is 77.6. Okay, so maybe you ask me now, why do I need to put my answer into this answer 77.6? Okay, so that's the reason actually. especially for statistics. Actually, it applies for all the maths paper in A-level, okay? But especially for statistics paper, you need to always remember the rules here. Okay, so remember the answer is 77.6. Now I want to show you something already. Okay, so I will stop sharing this file. Make sure you remember the answer is 77.6. Okay, so I will stop sharing this file and I will share another file with you. Okay, so the file that you see now is actually a past year paper, the original past year paper for year 2005. May, June 2005, and it is a statistics paper. So last time, statistics paper is paper 6, but now it changed to become paper 5 already. Okay, the name different, okay, the paper number different, but actually the syllabus are the same, more or less the same. Okay, so what I want you to have a look is, please have a look for the instruction here. This is the instruction, okay, so the standard instruction for A-level exam paper. Okay, so I want you to have a look here. Give non-exact numerical answer correct to 3 significant figure. So I think the very important thing here is please highlight the 3 significant figure. Okay, and what is the meaning of non-exact numerical answer? Okay, so non-exact numerical answer means that when you press calculator, right? Okay, the decimal number in the calculator is very long one. There's no ending point until they actually occupy until the very last digit of the calculator. So it requires non-exact numerical answer. So when you have this kind of answer, right, you have to actually write it into 3 significant figure as your final answer. Okay, and then for maths, you can write it for 1 decimal place for angle in degree. So we'll learn this in maths later. But for statistics, more related one is this one, the 3 significant figure case. Alright, so when you press calculator just now, you realize that the value is very long because it's 0.776119403. It is a super long answer. Of course, you can write in a super long answer. Therefore, your final answer should be in 3 significant figure, which is 77.6 only. Okay, so some students will ask, is it they are going to be so strict when you write out the answer like 77.61 or 78? If you write out this answer, non-3 significant figure, they will penalize 1 mark for your final answer. For me also, I will penalize. So make sure you are very aware of your final answer here. Understand? Okay, all right. So this is what we have for our histogram part. I know that these 2 videos are quite long. Okay, but I need to tell you all the details before you can try the exercise or tutorial question yourself. Okay, but of course, as what I said, when you go through with all this video, if you understand, doesn't mean that you really understand. You have to really try out the question on your own. Then only you know which part you understand and which part you don't understand. Okay, so please make sure you try to complete the tutorial question if I give you any later. And then I can't give you a lot of tutorial question for now for statistics because for statistics question, chapter 1, they actually try to combine a lot of things together. So we are now learning very limited topics only. So we actually cannot really get a good question for you to try. But no matter how, I will select a few to let you have a look or have a try how to draw the unequal histogram first. Okay, so that's all for this video. And then I will continue more maybe on the Friday class, all right? The face-to-face class on Friday. Okay, see you then.